when the bases of our exponential expressions are fractions, we have to be a little bit careful, but all the same rules really apply. For instance, if we have an example 3 over 4 to the power of 2, what does it mean to raise something to the power of 2? It just means write the base twice and multiply them. So a fraction times a fraction just ends up being one big fraction. On the top we have 3 times 3, which of course is 9, but if you write it with an exponent, it's just 3 squared. And on the bottom we have just simply 4 squared. So what have we done? We can think of applying the exponent 2 to both the numerator and the denominator. Now after that, if you want, we can simplify it further and write it as 9 over 16, but sometimes those bases are going to be variables, and you'll just simply have to write it as the variable to the power. So here's the law. If we have a fraction as a base, we can apply that exponent to the numerator and additionally to the denominator. And that law is going to be used quite frequently. Let's take a look at a similar example, but with a negative exponent. Now, we saw that with a negative exponent, I said the first thing you should think of is just simply taking the reciprocal of the base. So the base is a fraction, 2 over 5. Taking the reciprocal of a fraction just means flipping it. So this is the same as 5 over 2 with a positive exponent. And now we can apply the law we just learned. This is just simply 5 to the power of 3 over 2 to the power of 3. 5 to the power of 3, if you want to evaluate it, you can write it as 125, and 2 to the power of 3 is 8. So here's our second law using a negative exponent. You take the reciprocal of the base, b over a, and rewrite it with a positive exponent. Now, you may be saying, well, how come I can't just use the previous law and apply that negative exponent to both the numerator and the denominator? You can, but the problem is that you end up with an expression that's a little bit tricky to evaluate. So for instance, if you just applied the negative 3 to the 2, you would have 2 to the power of negative 3 over 5 to the power of negative 3. And using the laws we've already learned, 2 to the power of negative 3 is 1 over 8, or 1 over 2 to the power of 3. I'll write that first. And then we have 1 over 5 to the power of 3. So this is 1 over 8 divided by 1 over 125. Now, once you get fractions within fractions, most students start to have difficulties. It's not really all that difficult to deal with if you know a few techniques. And one of the easiest ones is to think of this as a division. If you have 1/8 and you're dividing it by 1/125th, you're dividing by a fraction. You can always turn that into a multiplication just by taking the reciprocal of 1 over 125. And so you could turn this into 1 over 8 times 125 over 1. And so you end up with the same thing, but it's much, much simpler to just simply take the reciprocal of the base and use a positive exponent. So let's try that on a couple of examples down here. 4 over 7 squared. You can write that as 4 squared over 7 squared, and if you want to evaluate that, you can write that as 16 over 49. 5 over 9 to the power of negative 2. Let's take the reciprocal of 5 over 9, write it as 9 over 5 squared. And this you can write as 9 squared over 5 squared. If you want to evaluate those numbers, you can write that as 81 over 25.